Hello everyone. Today, I'm going to show you an amazing transformation. We'll take this ordinary ferrite core, often just a component in old electronics, and turn it into a powerful functional TV antenna. Next, I'll wrap the entire ferrite core tightly with aluminum foil. This foil is crucial as it will act as a conductive surface for part of our antenna system, boosting its signal reception. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. After wrapping, I'll use a pair of scissors to trim off the extra foil. Then I'm gently pressing and smoothing the foil to ensure it conforms perfectly to the shape of the ferrite core, creating a clean, reflective surface. This ensures optimal signal reflection and less interference. With the foil wrapped, I'll use my utility knife to carefully cut out the center opening. This creates a clear path through the core, which is essential for the antenna's design and functionality. Precision here makes all the difference. I'm checking the fit of a standard PVC pipe elbow piece through the center of our foil-wrapped core. It fits perfectly. This piece of PVC will act as a guide for winding the copper wire for the antenna. Now, I'm taking a length of thin insulated copper wire. I'll carefully wrap it around the PVC pipe section several times. This creates our inductor coil, which is the heart of the antenna, capturing electromagnetic waves. After making several turns, I'll trim the wire, leaving enough length for connections. I'm carefully shaping the coiled wire, making sure the turns are even and secure. This coil is crucial for picking up TV signals, so I want it to be as neat and effective as possible. Next, I'm inserting this copper coil into the center hole of our foil-wrapped ferrite core. It should fit snugly. The ferrite core helps concentrate the magnetic field, significantly improving the antenna's reception capabilities. I'm trimming the ends of the wire that extend from the coil, ensuring they are of an appropriate length for easy connection later. This step prepares our coil for integration into the circuit. I have these small plastic connector blocks. I'm using a utility knife to cut them into smaller, individual segments. These will serve as secure points for connecting our wires without soldering. I'm inserting it into one of these connector blocks, then tightening the screw. A good, tight connection ensures proper conductivity for the signal. I'm repeating the process for the other end of the coil wire, securing it into a separate connector block. This prepares both ends of our coil for easy integration into the antenna circuit. Now, I have a small wooden block. This will be the base for our antenna assembly, providing stability and a mounting surface for all the components. I'm applying hot glue to the wooden block. This adhesive will firmly attach our ferrite core assembly to the base, making it a stable unit. I carefully press the foil-wrapped coil assembly onto the hot-glued area of the wooden block. I'll hold it firmly until the glue sets, ensuring a strong and lasting bond. Next, I'm disassembling a standard electrical plug. I'm removing the metal pins from inside. These pins will be repurposed as terminals for our antenna connections, offering a secure and conductive point. I'm stripping a short length of red wire and attaching one of the plug pins to its end, tightening it with a small screw. This red wire will carry one part of our signal. Similarly, I'll strip a blue wire and attach another plug pin to its end. The red and blue wires will form the primary connection from our antenna to the TV. I'm carefully integrating these wires with the pins back into the plug housing. It's essential to ensure correct polarity and tight connections for safety and functionality. With the wires secured, I'm reassembling the electrical plug. This part will connect our homemade antenna to an external power source or directly to the TV's antenna input. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. I'm stripping the other end of blue wire and inserting it into one of the connector blocks already attached to the coil. This connects the power side to our antenna coil. And I'm doing the same for the red wire, connecting it to the second connector block on the coil. Now, our coil is electrically connected to the plug assembly. To finalize the base, I'm hot gluing the assembled plug onto the wooden block, right next to the coil. This keeps everything tidy and secure, preventing any accidental disconnections. I will prepare another plug to connect the signal wire to the TV. For the actual antenna cable, I'm using a standard coaxial cable. I'll strip the outer black insulation to reveal the inner shielding and conductor. Proper stripping is key to a good signal. This leaves the braided shield and the inner insulated wire ready for the next steps. Now, I'll strip back the white insulation to expose the copper core. This central conductor carries the main signal. I connect the copper core to one pin of the plug and the side shell to the other pin of the plug. Secure it tightly with screws to ensure safe and continuous operation. After securing it securely, I put the two prongs back into the plug and tighten them. To give the cable a clean finish and added strain relief, I'm sliding a piece of heat shrink tubing over the connector junction. This will protect the connection and make it look professional. As the tubing heats up, it shrinks tightly around the connector and cable. creating a durable and insulated seal. I will connect the two plugs together, making sure they fit snugly. I'm preparing a second coaxial cable in the same way, stripping the outer insulation to expose the inner conductor and shield. Consistency in preparation is important for reliable performance. I then attach an F connector to one end of the coaxial cable. This connector is essential for ensuring a strong, reliable, and interference-free signal transmission from our antenna to the television. Finally, I attach a right-angle F connector to the other end of the coaxial cable. This angled connector makes it super convenient to plug into the back of your TV, especially in tight spaces. As you can see, the screen initially shows no signal. I'm carefully plugging in our homemade antenna to the TV's coaxial input. And there you have it. Look how perfectly it works. Instant, clear channels appearing on the screen. This simple DIY antenna, made from a ferrite core, is picking up a strong signal. I'm changing channels, demonstrating the antenna's effectiveness across various broadcasts. The signal is stable and clear, proving that with a little ingenuity, you can achieve amazing results with common household items. To really show you the difference, I'll disconnect the antenna. See, no signal immediately returns. But once I reconnect it, bam! Instant channels. It's working exactly as intended. And there you have it. Our incredible homemade TV antenna, created from a simple ferrite core and some common parts. Who knew you could get clear TV reception with a little ingenuity? This DIY device proves that with a little creativity, you can achieve amazing things and save money. If you enjoyed this project and found it inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me what other unexpected things you'd like to see me create. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next one.